Have you ever wondered why making moral decisions feels so hard, especially when the stakes are high and there are many factors to consider? This isn't just a human problem, it's a fundamental challenge for artificial intelligence too. The paper, Bounded Morality, introduces a groundbreaking framework that helps us understand why. It argues that moral reasoning, for both humans and AI, is a computational problem constrained by limited resources. The core idea of bounded morality extends Herbert Simon's concept of bounded rationality. Simon famously said, "Human rational behavior is shaped by a scissors whose two blades are the structure of the task environment and the computational capabilities of the actor." This paper applies that wisdom to morality, shifting the focus from just agent limitations to the inherent structure of moral problems themselves. It asks, what features of moral situations make them computationally demanding? The framework identifies two crucial, orthogonal dimensions that define the computational demands of any moral situation. First, moral breadth refers to the scope of entities, groups, or timescales considered morally relevant. Are you thinking about just yourself, your family, your community, or all of humanity, animals, and future generations? Second, moral depth captures the inferential complexity, how richly, recursively, and coherently you reason about these entities and their interactions. Are you using simple rules or engaging in deep counterfactual and principle-based deliberation? Here's the critical insight: because computational resources are finite, there's an unavoidable trade-off between moral breadth and moral depth. You can't maximize both simultaneously. Expanding your moral scope to include more entities increases informational load, while deepening your inference compounds computational demands. This creates a feasible space of moral computation bounded by a breadth-depth frontier. Any moral strategy must operate within this frontier, making choices about how to allocate its limited resources. This framework offers a fascinating reinterpretation of classical ethical theories. Instead of seeing utilitarianism, deontology, contractualism, virtue ethics, and care ethics as competing truths, bounded morality views them as different, locally efficient strategies for allocating resources within the breadth-depth space. For example, utilitarianism might prioritize broad scope with moderate depth, while virtue ethics might focus on minimal breadth and zero depth, relying on learned policies. Each theory is a characteristic solution adapted to different resource constraints and problem types. The paper also introduces formal notions of moral regret and moral progress. Moral regret is the expected loss incurred by using a bounded approximation compared to an unbounded ideal. Moral progress, then, isn't just about discovering new values or expanding moral concern, but about improving how we allocate our fixed resources to reduce regret, or by expanding our overall capacity through cultural, institutional, or technological changes. This means progress can happen by simply making better use of what we have. For AI alignment, this framework has profound implications. If human morality is inherently bounded, simply imitating human judgments might reproduce those limitations. Instead, the goal should be to design AI systems whose moral reasoning capacity can scale and be allocated effectively across breadth and depth, extending the developmental logic by which moral competence grows. This shifts the focus from copying human outcomes to replicating the underlying scaling relationship between resources and moral capacity. In conclusion, bounded morality provides a powerful lens to understand moral reasoning as a constrained computational problem. It reframes moral disagreement, heuristics, and ethical theories as predictable consequences of bounded computation, rather than failures of moral concern. By explicitly modeling representational scope, inferential depth, and computational cost, this framework highlights the structural trade-offs that any finite moral agent, human or artificial, must confront. It's a minimal computational lens that integrates insights from ethics, psychology, and AI.